Okay, so today another Dodge Ram 3500. Big ugly. 1-ton dually. Check engine light is on. Transmission apparently does not shift properly. I noticed this as soon as I put it in drive. Reverse, neutral, neutral, disappears, drive, not there, second is there, no first. So there may be a problem with that gear shift indicator. I'm going to try and scan it and see what kind of codes it's got. For some reason it doesn't want to talk to this vehicle. I've rebooted the scanner, I've started the software, I've cycled the VCM, and I got no communication with any controller on the network. Yet the instrumentation is working fine, the gauges are working fine. Usually if the network is faulty, there's a problem with the gauges. See, it has an aftermarket radio in it, but I don't think that has anything to do with it. I even tried scanning it in generic OBD2, and that doesn't work. I have scanned this vehicle in the past, but not in the last probably year, so something may have changed. Okay, give up already, you're not going to talk. So because I scanned it in the past, the history is there. What if I go into engine? No communication. Go into transmission. No communication. So is it a network problem that's causing the transmission issue? Very well could be, but we're going to try another scanner. So we'll try this MaxiSys scanner. Automatic selection, read the VIN. Two scanners that won't talk to the truck. Try manually IDing it. In both cases I got power to the DLC. Doesn't even look like it's going to talk to it. Okay, so let's put out the breakout box on the DLC here, have a look at the DLC pins, see if we got any kind of communication. Well, there's the breakout box installed in the DLC, and you can see we got grounds on pin 4 and 5, and we got power on pin 16. I don't believe we're going to have communication on CAN L and CAN H until we try to talk to it. And when I use the scan tool and try to talk to the engine control module, you can see that it initiates communication on these two circuits, CAN H, CAN L. But it doesn't communicate. When I stop communication with the scan tool, it stops. Now, if we look at the network here, it goes from pin 6 and 14 of the data link connector through connector 219 to the TIPM. So it's not like a conventional network. This has a CAN diagnostic network specific specific to the TIPM. Now, he did indicate to me yesterday that he replaced the TIPM with a reman TIPM, and I'm wondering if there's wiring issues, but I can't get communication, and it doesn't appear that this vehicle supports OBD2 communication, but I'm not sure. Well, maybe it does. PCI bus on pin 2. Pin 2 is this circuit here. It should communicate through the PCI bus in OBD2 language, but it doesn't communicate with that either. But I'm not sure if the scan tool uses the CAN communication for this or not. So I'm going to have to get at the bottom of that TIPM and check termination resistance. Well, across pins 6 and 14 I got 72 ohms. It should be 60. And I think the spec is 58 to 62, and I got 72. I'm going to try it with the battery disconnected, although I didn't see any voltage on those two wires, so I assumed it would be good to check it. So I didn't see a voltage before with my Varus because I had the voltage level set on the lab scope at 5 volts, and in actuality I've got 11.8 volts on both CAN bus circuits, and that's not right. 11.8 volts. Let's move this ground over here just for shits and giggles, although it shouldn't matter. No, it doesn't. 11.8 volts. So the CAN bus, or at least the diagnostic CAN bus, is shorted to 12 volts. Let's turn the key off, see if that goes away. Oh, the key is off. With the key on, it's the same. Drops a little bit. I wonder if that TIPM that he put in is the problem. So in the schematic it shows the CAN diagnostic going through C219, which is a big bulkhead connector under the driver's side of the dash. So we'll have a look under there and see if we can see anything at all. So that big white connector that you see there is C219, and I can see there's a remote car starter tied to the side of it. There's a whole bunch of wiring here that is jimmy rigged. I'm gonna wiggle the connections here or wiggle the harness here and see if there's any change in voltage. Oh, look at that. Something's going on there. I wiggled that connection and now it dropped to 0.5. There we go. It's back up to 11.3. Something's going on in there. I'll have to have a look. So I took that connector apart. Can't see anything visually wrong with it. Reconnected it, and now both circuits are sitting at 2.5 like they should be. And I wiggle the connections and wiggle the harness and move it, and nothing changes. Let's see if we got communication now. So we'll see if we got communication with the engine controller now. Yeah, we do. Okay, let's go back and do a network code scan. Got the key on, engine off. I don't know what was going on in that connector. I didn't see any moisture or water in it. Camshaft position sensor performance. Fuel injector group 1 supply voltage circuit, pressure control solenoid circuit. Maybe he doesn't actually have a tranny problem. Maybe he's got a reduced engine power due to these camshaft codes and such. Rear speed sensor circuit, battery voltage low, ignition run only on input, lost communication, vehicle security. Now some of these codes I may have generated by disconnecting that connector. Well, I think we're going to start with a clear codes. I wonder if we should look at any freeze frame data. No, we're going to start with a clear code, network code clear, and then go for a road test and see what happens. Well, it says it cleared all codes from 10 modules. Let's go back into the engine here. No codes. Okay, we're going to take this thing for a road test and see how the transmission performs now. Well, the P0748 code for governor pressure reset before I even made it out of the shop. Check engine light is back on. Actual governor pressure is 0. So there's a problem with the governor pressure sensor, which is fairly common on these, I believe. Here's actual governor pressure right there. There should be a voltage here too. Got, yeah, 0.45. Let's turn the key off and back on. See what it reads. I noticed the batteries are pretty weak on this thing too. I believe there's an updated governor pressure sensor on these things because they do fail. Although this truck I think is stock, so it's usually not a problem. So it shows C108 in the center left side of the firewall, and that's a 14-pin connector, and I've got a 12-pin connector, and the colors don't match. This is what I'm looking at here. This is C130, and this is supposed to be C108, but this has only got 12 pins in it. This dark green wire does match pin 1 here. Dark green in the governor. But the rest of the pins don't match, so I don't know what's going on here, and I don't see any other connectors in this general area. This is supposed to be where C108 is. So here's an article on Identifix on that P0748 code, and it appears that 12-pin connector is in fact C108, yet in the schematics it shows it as 14 pins, and the colors don't match. So I'm going to follow these instructions here because it appears that the service literature is wrong. We'll have a look at measuring the resistance of that sensor. So in Identifix here it mentions to check the voltage on the yellow orange wire at pin 2 of C132. In the schematic it's connector 108, which is 14 pins. Here it says this is a 12-pin connector just to the left side of the center of the firewall. That's definitely what I have. And I do have a yellow-orange wire in pin 2 of that connector. Now C132 in here shows a yellow-orange wire in pin 2, and it is circuit T16. And on this schematic here, circuit T16 is should be the power feed to the governor pressure regulator right here. So that comes from the integrated power module, and that should be 12 volts. And that is sent to the module and then through the module to pin 1, which is the dark green wire. I've got no voltage on pin 1, and I got 5 volts on pin 2 of this connector. Well, according to this, it says check the voltage on the yellow-orange wire, pin 2 of connector 132. I should have 12 volts there. Check the voltage. It doesn't say what it should have. This is a 12-pin connector just left of center of the firewall. The harness leads down to the transmission. I have 5 volts on that wire, which sounds like it's a sensor wire, but that wire, according to this diagram, is T16, and T16 is actually the supply power to the solenoid here. Where are we? Right there. And that comes from the integrated power module. So I flipped this new integrated power module over and look at this rat's nest. I don't even know where to start. I'm absolutely amazed this thing actually runs. I don't know what all this stuff is in here. All these wires left disconnected. Fuses, inline fuse holders, wiring. Just a bloody nightmare. Where do we even start? Wow. So that power feed comes from connector C10 on the integrated power module, which in this beautiful glorious diagram looks to be the bottom connector on the module, which is down there. So I've got a back probing pin in terminal 9 of C10 here, which is actually yellow-orange wire. You can see it's in there, barely see it in there. And I've got 0.13 volts on here, yet over at that connector over there I've got 5 volts, so I'm confused. I can't see any breaks in this wire. I'm going to disconnect this connector and check for continuity from there to the over to that connector. So I've got C10 disconnected, terminal 9 in that connector, and I've got 1.7 mega ohms of resistance on that wire to that wire there. And if I disconnect the terminal, it goes infinite. I'm going to disconnect that connector back there as well. So after disconnecting that connector, it turns out there are 2 yellow-orange wires. This is not pin 2, this is pin 2. This wire color doesn't match the schematic, but this whole truck is a mess. And this connector doesn't match. This is C132. So anyways, that yellow wire has continuity to the TIPM. I'm going to check to make sure it's not shorted to ground. And it's on 40 ohms, so I'll put it up to 400K. And I've got it in that wire, and I'm going on ground, and I have no, sorry for the glare, I have no short to ground. So let's go back and plug this back in and see if we have a voltage on this wire. So with connector 132 plugged back in on that yellow-orange wire, which is the feed wire to the actual governor pressure regulator, it's 0. So it's like the circuit is shorted. I did have 12 volts coming out of the TIPM here. I'm going to try unplugging this again and rechecking it, make sure. So with the connector unplugged, pinning the connector on that pin, I have 12.3 volts, have the key on obviously, battery charger hooked up. So that circuit is either shorted to ground or the governor pressure regulator is shorted. Let's see if we can measure the resistance of the pressure regulator. So I decided to load test this supply voltage circuit to from the TIPM to this connector, and I'm using the Load Pro here. As I noticed yesterday when I was testing it, with the connector unplugged I had basically battery voltage there. Now with the key on I've only got 10.29. I've got the Load Pro plugged in here, so the Load Pro will put about a 500 milliamp draw on that circuit. Watch what happens when I press the button on the Load Pro. So there is a compromised wire between the TIPM and this. There's got to be a green corrosion in that wire. So again, when I press this button on the Load Pro, it puts about a half an amp draw. It's like putting a load test light in the circuit, and you can watch the voltage drop. So there is a problem with the wiring from the TIPM to that connector. So I've got a piercing probe. Yes, I know it's a piercing probe. in that wire leaving the TIPM, and key is on, and I'm currently reading 10.3 volts on it. I'm going to press the load probe button, and as you can see, it drops to 0. So the problem is actually in the TIPM, not in the wiring. As soon as there's a load on that circuit, it fails. Now, he told me he changed this TIPM for other issues. He didn't have he had the transmission problem prior to that, so I'm not sure what to believe now. I'm going to put power to that wire and see if it corrects the problem. So this is with the truck running. I just started it. Ramps up to about 15 volts. Now I'm backpinning that wire now, and if I press the load probe button on that wire now, it doesn't drop. So I'm thinking that the TIPM only supplies power if it's running. I didn't do this running, I had the key on. I don't know why the charging system's acting like that. Maybe that's the intake heater cycling on and off. Yeah, I'm sure that's what it is. The intake heater should be cycling on and off. Yeah, the intake heater is working. Look, that cable is. So I got no MIL, no codes in the transmission, and it still feels like it's starting out in third gear. I'm going to have a look at our tranny data. Here's my actual trans governor pressure, and I have it in drive right now, and it's 0. But the target pressure is also 0, which doesn't make sense. Nowhere in here does it show me what gear it's commanding the transmission to be in. It's like they forgot about that. I'm sure that's a data parameter that's available. Torque converter clutch, transmission output, shaft speed, but no current gear or commanded gear. So according to these instructions, with the key on, engine off, you must use a scan tool to actuate the transmission control output in the ECM. It's not in the ECM, it's actually in the TIPM. And that they tell you to use a 12-volt test light connected and back pin the TIPM C10 harness connector, circuit T16, which is pin 9, which goes to that connector on the firewall there. So it appears that unless the engine is running, there won't be power to that transmission. There may be a voltage present there, but it won't sustain any load, so that threw me off. Well, I've got a governor pressure regulator and a governor pressure sensor on order for this thing, and we're going to pull the pan down and have a look at the valve body and do a service and change those two parts in there. So I removed the governor pressure control solenoid and pressure transducer, and I measured the original one, and it was 3.6 ohms, and I compared it to the new one. The new one was 3.6 ohms. So I'm not confident that that's going to fix the problem, but these are new parts that are in the pan now. But under closer examination here, I'm looking at the wiring harness up here. I don't know if you're going to be able to see it here. You can see that green spot in the harness there. Up behind there's a connector there, which appears to be that 14-pin connector they said was supposed to be on the firewall. It's actually attached to a bracket on the back of the bell housing. And that appears to be, there appears to be a corroded wire there. Right there. Anyways, We're going to take that harness down and see if we can fix it. So I managed to get the harness pulled down, and there's the section where the wire is compromised. That green wire is the governor control wire. I don't know what the other one is, but that was a challenge to get that connector down. And that's that 14-pin connector that they said was supposed to be beside the firewall. 1, 2, 3, 4, 5, 6. No, that ain't 14 pins either. 1, 2, 3, 4, 5, 6. Yeah, it's 14 pins. Oh well.